Welcome to solverfy.
Okay, in this problem, we've got to determine whether the metal is a type 1 or type 2, and then give the formula for the compound. Formula. Okay, so type 1 metals always have the same charge, and they are in, sorry, not row, they are in group 1 or 2. Okay, and then type 2 metals are your transition metals, and they have variable charge. Okay, there are some exceptions to this. For example, silver is always +1. Although in this particular example, I don't see any of those exceptions. So for our purposes, group 1, group 2 will be type 1, and then transition metals will be our type 2 metals. Okay, so to begin with, we have copper to oxide. Copper is not a group 1 or group 2 metal. It's a transition metal, so its type is 2. Then the formula, because it's a type 2 metal, means it can have multiple different charges, so we have to specify in the written formula exactly what the charge is. And then what determines the charge is our anion, right? So oxygen always has a 2 minus charge. So if 2 coppers and 1 oxygen is overall neutral, then each copper must be +1, right? Because 2 plus 1s and a -2 equals 0. Okay, so the formula then is going to be copper. And then we specify the charge in parentheses using Roman numerals. So we'll say copper 1 oxide. Okay, next one, we've got magnesium nitrate. Okay, magnesium, that's a group 2 metal, right? So that means it's a type 1. I know it's a little confusing, but that's, group 1 or group 2 is type 1. Anything else, unless it's something like silver, is going to be a type 2. Okay, and because we know that magnesium is in the second column of the periodic table, that its charge is 2+, and it's always 2+, so we don't have to specify it in the formula. Anytime you see magnesium, it'll be 2+, so there's no use writing it out as the idea. Okay, so we can just write magnesium, and then the name of our polyatomic anion is nitrate. Okay, let's continue. Next, we have iron chloride. Okay, iron is a transition metal, so this is going to be a type 2. Its charge will be determined by the anion. We have 2 minus 1 anions, so the iron must be 2+ if a single one of them combines with 2 negatives to make neutral. Okay, so then we say iron, the charge in parentheses using Roman numerals, iron 2 chloride. Okay, keep going. Now we've got titanium phosphate. Titanium is a transition metal, so it's type 2. Phosphate has a charge of -3, so the titanium must be 3+. Titanium 3 phosphate. Okay, next up we have potassium phosphate, K3PO4. Potassium, that's group 1, so it's a type 1 metal. Potassium, because it's in group 1, always has a +1 charge. That's why we have to have 3 of them to counteract the 3 minus from the phosphate. But we don't specify the charge because it's group 1 or type 1 in this case specifically. So potassium phosphate. Okay, and finally we have vanadium. Oops, it's supposed to be a 2, not an S. Vanadium sulfide. Okay, sulfur, just like oxygen, always has a charge of -2. Well, for one, vanadium is a transition metal, so that's type 1. Okay, sulfur always has a charge of 2-. And we've got 3 of them. So the sulfur adds up to 6-. If 2 vanadiums counteract 6- completely, then the charge must be 3+. So we say vanadium 1, 2, 3, put the charge in Roman numerals in parentheses, and then the anion sulfide.